present here. Today we are going to see about transformers that comes under unit 2 of BEIE. So introduction of a transformer. A transformer is a device for increasing or decreasing an AC voltage. Here we are having primary winding and secondary winding. The primary winding is given to the AC generator and secondary winding is given to the CRO. What CRO? Cathode ray tube. So primary winding is less and secondary winding is high, so we can say it is a step down transformer. If the primary winding is more than the secondary winding, we call it as a step down, otherwise it is step up transformer. A transformer consists of primary coil and a secondary coil, both wounded on an iron core. The changing magnetic flux produced by the current in the primary coil induces an EMF in the secondary coil. A transformer is a device that changes the AC voltage at one electrical level to AC power at another electrical level. Transfers electrical power from one circuit to another. It does so without a change of frequency. It accomplishes this by electromagnetic induction. In terms of number of windings, conventional transformer 2 windings, auto transformer 1 winding, others more than 2 windings. In terms of number of phases, single phase transformer, there are two types, single phase transformer and 3 phase transformers. The classification of transformer, it is step up transformer and another one is step down transformer. So depending on the voltage level at which the winding is operated, step up transformer has a low voltage winding and step down transformer has high voltage winding. So step up is used in electrical and electronics, and step down is used in electronics and communication because we are dealing with 12 volt to 15 volt. So different types of transformer, one of the type is core type and another one is shell type. So here we will see the core type. So core type, here in the first diagram it can be represent the front diagram, second one is the construction. In the first diagram we are having an yoke, then core, limb and the flux. When the input is given at the N1 primary, the output magnetic flux induced in the secondary also based on the primary input. The magnetic flux will be flowed over the entire coil. You will get the output at secondary. Windings are wrapped around the two sides of laminated core. See, this is a sectional view of transformer. One is high voltage winding, another one is low voltage winding. So there are two types, one is shell type, another one is core type. You can see in the diagram. High voltage conductors are small cross conductors than the voltage coils. So here the core type, various types of cores we can see in this diagram. Next one is shell type. The HV and LV are windings split into number of sections, where HV winding lies between two LV windings. In such sandwich coils, leakage can be controlled. So this is a cross-sectional view of a transformer in which we are having a winding, then core, conservator, high voltage terminal bushing and low voltage terminal bushing. Next one is we will consider for an ideal transformer. In ideal transformer we are having V1 is supply voltage and no node current, V2 is output voltage and I2 is the output current, and IM is the magnetizing current, E1 is the self-induced EMF and E2 is mutually induced EMF. Next one is EMF equation of a transformer. We will consider let N1 be the number of turns in primary winding and N2 be the number of turns in secondary winding, and phi m represents the maximum flux in the core in Webers. So flux can be written as phi m equal to Bm into A, where F is equal to frequency of AC input. You can see the diagram of an AC. E1 is the EMF produced in the primary and E2 is the EMF produced in the secondary. As shown in the figure, the flux increases from its zero value to the maximum value phi m in the quarter of the cycle in 1/4 second. Average rate of flux phi m is equal to phi m divided by 1/4 frequency. That is equal to, the frequency will be written in Webers, 4f pi m W by S or volt. Average EMF per turn is equal to 4f pi m volt. If flux phi m varies sinusoidally, then the RMS value of the induced EMF is obtained by multiplying the average value with the form factor. Thank you.